Hello everyone and welcome to this session on Introduction to Industrial Instrumentation. In this lesson we'll explore the foundation of how instruments help us measure, monitor, and control processes across industries, from oil and gas to power generation, manufacturing, and even healthcare. So by the end of this session, you understand what instrumentation really means, its purpose, and why it's the backbone of modern automation systems. So what is industrial instrumentation? Instrumentation is a science of automated measurement and control. So in simpler terms, it's about using instruments to measure variables like pressure, temperature, flow, or level, and using that information to control processes automatically. So it's not just about reading numbers, it's about ensuring consistency, safety, and efficiency in the operation of refinery floors, water treatment plants, because instrumentation keeps things steady and predictable. So everywhere you look, you'll find instruments silently doing their jobs. They're measuring speed, maintaining altitude, monitoring dosage levels, and ensuring product quality. So without these measurement systems, most of today's technology would simply fail to function. Now, think about it. The first step in any automation process is measurement. And if we can't measure something, it's impossible to control it. Now think about it. How would you control the temperature of a furnace if you didn't know how hot it was? So in the industry, we commonly measure variables such as pressure, temperature, flow rate, level, chemical concentration, and we even count objects on a production line. So all these values help control systems make the right decisions automatically. Now, accuracy is not just a technical requirement, it's the difference between safety and disaster. And in oil and gas, a wrong pressure reading could lead to a shutdown or even an explosion. And in pharmaceuticals, a small deviation in chemical concentration could make a drug unsafe. So every instrument we use must be carefully selected, calibrated, and maintained to ensure precision. Now, if you look, you see a flow transmitter. Now, this flow transmitter senses the flow rate and then it sends the signal to the PLC. The PLC then decides on what to do, and then it sends a signal to the control valve to either shut it down or open it fully. So this final control devices usually takes some or one of the following forms, but we're going to be focusing on two, which is the control valve and the electric motor. So every instrumentation system has three main parts. We have the sensors or the transducers, which detect physical quantities like pressure or temperature and convert them into electrical signals. We also have the transmitters that send those signals over distances to a control system. And we have our controllers and indicators that interpret these signals and make decisions, just like turning a pump on or off. So together, all of this forms a complete loop that measures, transmits, and control. Now in the image you're seeing here, you're seeing what we call the process and just what I explained to you. So it's a loop. So together they all form a complete loop. So now, industrial measurement and control systems, they have their own unique terms and standards. And here are some common instrumentation terms and their definitions that I would like us to know. So the common instrumentation terms and definitions, we have the process, which is a physical system we are attempting to control. We have the process variable, otherwise called the PV, which is a specific quantity we are measuring in a process. We also have the set point, or SP, which is the value at which we desire the process variable to be maintained at. In other words, the target value for the process variable. We have a primary sensing element, or PSE, which is the device that directly senses the process variable and translates that sensed quantity into a standardized signal that we can then measure and follow up with. We have a transducer in instrumentation. We have transmitters, which are devices that translates the signals produced by the primary sensing element into standardized instrumentation signals, such as the 3 to 15 psi air pressure or the 4 to 20 milliamps electric current. We also have the lower and upper range values, abbreviated as LRV and URV respectively. We also have the zero and span terms that are like alternative descriptions to the lower range values and upper range values. We have a controller, which is the device that receives the process variable signal from a primary sensing element or a transmitter, then compares that signal to the set point for that process variable, and then calculates the appropriate output signal value that will be sent to the control element, the final control element, such as our valve, our control valve. And then our final control element is also another term in instrumentation, which describes the device that receives the signal output by a controller to directly influence the process. We also have the manual mode and the automatic mode. Okay, so the manual mode has to do with when the controller's decision-making ability is bypassed to let a human operator directly determine the output. And in the automatic mode, the controller generates an output signal based on the set point it was given. So summarily, as instrument technicians or engineers, our role is to ensure all these systems work reliably and safely, because we install and calibrate and troubleshoot and also maintain instruments that keep industrial processes running smoothly. So our job is it requires a broad command of technical skill, because it's a mix of electrical, mechanical, and digital skills. And it's one of the most vital roles in the industrial world. So to summarize, industrial instrumentation is the heart of automation. It's what allows industries to operate efficiently, safely, and consistently. And we've seen how measurement forms the basis of control, and how instruments turn data into action, and how automation surrounds our modern world. So in our next sessions, we'll go deeper, exploring sensors, transmitters, and control loops in detail. Thank you for your time, and welcome again to the world of industrial instrumentation. Thank you for watching. If this video helped you, please like, subscribe, and share, and I'll see you on the next one.